Welcome to the GenAI and MLOps practice series from the AI Mock Interviewer Question Bank. GenAI and MLOps Part 1. This episode has 11 questions. For each question, take a moment to think through your own answer before I share a strong approach. Question 1. MLOps or AI Infra. MLOps Fundamentals. Explain the end-to-end ML lifecycle and where DevOps responsibilities become different from traditional application delivery. Here's a strong way to approach it. The ML lifecycle spans data collection and validation, feature engineering, model training and evaluation, deployment, and ongoing monitoring for drift, with a feedback loop back to retraining that traditional application delivery doesn't have. DevOps responsibilities differ because correctness isn't just whether the code runs, but whether the model's predictions remain accurate over time as real-world data shifts, which requires monitoring data and prediction distributions in addition to standard application health metrics, and versioning data and models alongside code. Nice. Let's continue. Question 2. GKE or Kubernetes. GKE multi-tenancy. How would you design namespace isolation, quotas, RBAC, network policies, admission controls, and observability for many teams in one cluster? Here's a strong way to approach it. Give each team a dedicated namespace with resource quotas and limit ranges sized to their needs. RBAC role bindings scoped strictly to that namespace, and default deny network policies with explicit allow rules for legitimate cross-namespace traffic. Enforce baseline security standards. Non-root. Resource limits required via admission controls like Gatekeeper or Kyverno applied cluster-wide so no team can opt out. And provide per namespace observability dashboards so teams can self-serve visibility into their own workloads without needing cluster admin access. Great. Moving on. Question 3. Observability. Trace sampling. How would you choose tracing sampling rates and make traces useful for debugging high-volume services? Here's a strong way to approach it. Use a lower sampling rate for high-volume, healthy traffic to control cost and storage. But always sample 100% of traces that contain errors or exceed a latency threshold. Tail-based sampling. Since those are exactly the traces you need for debugging and a random low-rate sample would likely miss them. Ensure sampled traces include enough context, all relevant spans across services, not just the entry point, to actually be useful for root-causing an issue, not just confirming a request happened. Alright, next question. Question 4. Security or DevSecOps. I am troubleshooting. A workload gets permission denied only in production. How would you debug IAM policy, service accounts, workload identity, org policy, and audit logs? Here's a strong way to approach it. Compare the exact service account and IAM bindings between the working environment and production first, since a permission denied only in production issue is usually an environment-specific difference, not a code bug. Check workload identity bindings are correctly mapped for the production namespace or service account. Verify no org policy constraint is more restrictive in the production project or folder. And check cloud audit logs for the specific denied call to see exactly which permission was missing rather than guessing. Let's keep going. Question 5. Automation or platform. Platform API. If you expose self-service infrastructure through an API, what validations, approvals, and audit trails would you build? Here's a strong way to approach it. Validate every request against schema and policy checks, quota limits, naming conventions, allowed resource types before provisioning, and require an approval step for anything above a defined risk threshold while allowing routine, well-understood requests to auto-approve. Log every request, decision, and outcome with who made it and when, so the audit trail can answer who created this resource and under what approval months later without needing to reconstruct it from memory. On to the next one. Question 6. GCP services. Log correlation. How would you design correlation IDs and structured logging across microservices and async pub or sub workflows? Here's a strong way to approach it. Generate a correlation or trace ID at the entry point of a request and propagate it through every synchronous call via a standard header, and explicitly carry it through asynchronous hops by embedding it in pub or sub message attributes, since it won't propagate automatically across a queue. Use structured JSON logging everywhere with the correlation ID as a consistent field name, So a single query across all services logs reconstructs the full request or event flow even when it spans both synchronous and asynchronous legs. Good. Here's another one. Question 7. MLOps or AI infra. Model monitoring. How would you monitor model serving for latency, error rate, drift, data quality, and business impact? Here's a strong way to approach it. Monitor serving infrastructure metrics, latency, error rate, throughput, the same way you would any production service, and layer in ML-specific monitoring, input data quality checks, schema validation, missing or out-of-range values, prediction distribution drift against the training baseline, and where possible, business outcome metrics tied to model decisions, conversion, revenue impact. Since a model can be technically healthy while quietly hurting the business, alert on each category with different urgency and routing, since a latency spike and a slow drift trend require very different responses. Nice. Let's continue. Question 8. GKE or Kubernetes. Kubernetes certificate issue. A cluster has certificate or webhook TLS failures. How would you debug certificate chain, rotation, admission webhooks, and API server errors? Here's a strong way to approach it. Check the API server logs for the specific TLS error first. Expired certificate, untrusted CA, hostname mismatch all produce different messages, and verify certificate expiry dates for the API server, kubelet, and any admission webhook certificates. Since GKE typically rotates these automatically but a self-managed or third-party webhook certificate can expire silently. If an admission webhook is failing TLS verification, check its certificate is signed by a CA the API server trusts and that the webhook CA bundle configuration in the cluster is current. Great. Moving on. Question 9. LLM Ops or GenAI production. How would you design a production LLM-backed service on GCP, covering the API gateway, model routing, caching, observability, and cost controls? Here's a strong way to approach it. Front the service with an API gateway handling auth, rate limiting, and request validation, route to the appropriate model, Vertex AI endpoint, self-hosted VLLM, or third-party API, based on task complexity and cost trade-offs, and cache responses for repeated or semantically similar queries where the use case tolerates it. Instrument full request tracing, prompt, retrieved context, token counts, latency, model version, for debugging, and enforce per diem token budgets and cost alerting so spend stays visible and controlled rather than discovered at the monthly bill. Alright, next question. Question 10. LLM Ops or GenAI production. A retrieval augmented generation pipeline returns stale or irrelevant context. How would you debug the vector database, embedding pipeline, chunking strategy, and retrieval ranking? Here's a strong way to approach it. Check whether the underlying source documents have actually been re-indexed after updates. Stale context is very often simply an indexing pipeline that isn't keeping up with source data changes, not a retrieval algorithm problem. If context is irrelevant rather than stale, evaluate chunk size and overlap. Too large dilutes relevance. Too small loses context. Verify the embedding model matches between indexing and query time, and check retrieval ranking. Sometimes the right chunk is retrieved but ranked too low to make the top K cutoff, which re-ranking or adjusting K can fix. Let's keep going. Question 11. LLM Ops or GenAI production. How would you build an internal LLM gateway that handles authentication, per diem rate limiting, token budget enforcement, and multi-provider fallback? Here's a strong way to approach it. Build a proxy layer that authenticates each request against team-scoped API keys, enforces per diem rate limits and cumulative token budgets tracked in a fast shared store, Redis, and routes to the configured primary provider with automatic fallback to a secondary on timeout or rate limit errors. Log every request with team, model, token usage, and cost for accurate attribution, and expose usage dashboards so teams can self-monitor their consumption against their budget. On to the next one. That wraps up this episode. Nice work practicing, and see you in the next one.